Hi, my name is Noah Gift, and I'm going to be your instructor for this course. We're going to dive into how to do data science in Python with Colab Notebook and Pandas in 1 hour. First, I show you how to use Colab Notebook to ingest data, perform exploratory data analysis, do plotting, and then later use that to come up with a solution for your business leader. Then I dive into how to use AWS to look at no-code and low-code AI solutions like AWS Comprehend to do natural language processing and also AWS Rekognition to do computer vision. Then I dive into the terminal, use Cloud9, and look at different approaches to programmatically accessing those same resources. Let's go ahead and get started. And let's walk through an exploration. For example, that maybe some of this could be if someone was going to focus on COVID, for example, this could be a good example of what you could do. Notice that at the beginning here that I create these cells that give a structure where there's the ingestion of the data, there is the exploratory data analysis of the data, there's the modeling section, and there's a conclusion section. A lot of times this is an effective formula for building a data science notebook. If the classes I teach at Northwestern, at Duke, when I teach them, or at UC Berkeley, when I teach a machine learning class, I recommend this is that there's 4 distinct sections: the ingestion of the data, the exploratory data analysis, the modeling, and the conclusion. So the conclusion would be where you would write something to the business leader and you would make your recommendation like, we should move to Austin, Texas. It will save the company $10 million. So it's possible that the business leader only reads the bottom, but then they may give the report to somebody else on their team to investigate and double check that you actually have correct data. And so that's why I think this structure is a very good structure. So let's walk through how this works. So the first part here, when I ingest the data, notice that I'm pulling data from a publicly addressable URL so that you can recreate the same thing. I just gave you a link. You can do everything that I did. You don't have to email me and say, hey, your libraries don't work, or I can't find your data. It's a reproducible. So that's another important step in doing data science, is that it's 100% reproducible. And again, in this example right here, notice that we have the cases, the deaths, and then I could start to explore the data. So then if I want to look in Python here, if you're not familiar with pandas, really in 3 lines of code, you can explore any type of a spreadsheet by saying import pandas as PD, make a data frame. So think of a data frame as a spreadsheet. It's like columns and then rows. And then I say head, and all head does is it shows you the first 5 rows when you do head. Now, if you want to do more, you can do this. You can say I want 10 rows, and you can go through here and it'll pull 10 rows. If you want to look at the last rows, they have a tail. So this DF here, let me just show you this real quick. The DF, if I type it in and I click dot and I do tab, or it'll autocomplete and it'll show everything I can do. So it's almost like a menu of different things that I can do. So that's a very important thing to know about with these. This is called Colab Notebook, which is a hosted version of Jupyter Notebook, is that if I click on the dot, it'll automatically show me everything, all the different things that I can do with this. In this case, I could even look down to, tail like this, and it shows me right there what it does. Right? It says it gives by default five things. And in fact, I can even do this if I want to find out about something. If I do question mark and I do ShiftReturn, it'll even give me the documentation. And it'll tell me, oh, look, what does this do? This returns the last n number rows. This function returns rows from object based on position. It's useful for quickly verifying data, for example, after sorting or appending rows. So I can look at every single thing that this particular method does and even look at examples, for example. So this is an important way to learn Python on your own, is to use the interactive help by doing this question mark here. So again, we look at this this tail operation. We can just run this, and we can see the last 5 states here. Now, as I mentioned before, with almost all data science with Python, you use pandas for this kind of data science, and it's columns and rows, and the columns are the names, right? And so in this case, if we go back again, right here, look, you can see it says this is the index, this is the date, this is the state, this is the FIPS code, the cases, and a death. So how do I do this? I can just type in df.columns, and it will just tell me every single one of the columns. So that's another good way to explore the data, is to look at the column. So let's say that you're dealing with a data set that you downloaded that has, let's say, 10,000 columns, which is possible. You might want to do df.columns first, just so you can see what's happening, because if you try to print it out, there'll just be too many, and it'll truncate it. But if you do df.columns, you could even, turn that into a list. For example, you could do this, right? You could put this into a list, and then maybe just look at 0 through 4, something like that, right? So it's a good way to kind of play around a little bit or truncate it by looking at just the columns. The other way that a lot of data scientists explore a data set as well is they use something called df.shape. And what df.shape does is it shows the physical attributes of the spreadsheet. So it would be like if in Excel, you would say this document has 18,714 rows. That would be similar, but in this case, it shows you the rows is the first value, and then the columns or the different header names, there's 5, right? So you can visually look at this, and this is very important for a couple of different reasons. One, I would say you always should do this when you upload a data set. But two, that if you're going to drop data, so this happens a lot, is if you have missing values. Let's say you're working with the Titanic data set as a very popular data set on Kaggle. You have to drop some of the values because they're missing, unless you do some kind of data science technique to fill in those values. And then you can visually see, look, there's rows that have been dropped, or there's columns that have been dropped. So this is an important kind of a quality control check to run a lot, is to look at the shape. Okay, so that's just the ingestion phase. Now, why I like this style is that this is taking up a lot of room. So I played around with it. I understand what the ingestion is now. Then I just close it, right? And then it goes away. Now I don't have to look at that. Now I can focus on the next section, which is now I want to explore the data set. So I want to do exploratory data analysis. And in this particular example, what I will do is describe the data. Now, what does describe do? It's a shortcut for descriptive statistics. So it's intuitively, what you would think about if someone asked you, let's say that you saw someone, break into a store, and the police asked you a question, who is the person? Maybe you say they're 6'2", they're 300 pounds, they were wearing, purple shirts, they had a basketball with them. Maybe they were a professional basketball player, right? That's the same concept. Is df.describe here? Is it shows you the count, right? So how many different rows there are. It shows you the mean, which is the average. And remember that average is very sensitive to outliers. So average is a little bit dangerous to try to make too many assumptions about the data. And then also standard deviation, which is shows you what is the average distance between the values, the minimum value. So in this case, you can see that the minimum number of deaths was 0, the 25th percentile, the 50th percentile, that would be the median, the 75th, and then the max. So you can see in one of these states, I think would this be in I think, is it in a month or is it in a day? Maybe it's a day. I think there might have been one day that 44,000 deaths, which is a lot of deaths that occurred. But again, this is the descriptive technique. This one shows the scatter plot. And so this is also a very common thing to do in showing when you first start looking at the data. It's a very good idea to just do a plot. Just look at what's happening here, and so you can see that there's definitely something happening, which is that this is the number of deaths here, and these are the number of the cases. That in some of these states that we're looking at, notice that the curve has significantly flattened. Right, it was exponential number of deaths, and now it looks like it's logarithmic, right? Because all growth that's biological in nature, that eventually will be a logarithmic, right? It may start with exponential, but then there's only so much that can occur before it can't continue at an exponential rate. So you can see this was, whatever this state is, it's smoothing out. But then maybe this one was really slow, and now is starting to get exponential, right? So this again just gives us some visualizations of what to look at. So the key things to be aware of here are that the X is one of the columns, and the Y is another one of the columns. So you can swap this with whatever column you would like, and then you can also do the hue here with a continuous column. So if the data is essentially numerical and is continuously numerical, then the hue can plot the gradient, right? So it can plot darker or lighter. And then also with this particular library, you also could do different things, like you could make the size bigger, right? So in this case, we make if the larger amount of deaths, the size gets bigger. And then right here is where you populate the data frame, right? So you go through here and put in the pandas data frame. So this pattern would fit with any kind of a data set that you want to use. Now, the other thing you can do with pandas is that you can look at date-based exploratory data analysis. So let's go ahead and look at this. Here's an example of dealing with dates by setting an index on the dates. So I say df is equal to pd.readcsv. So I go through and I look at the US states here, and then I set a column called date. So I add a new column. So in pandas, just like in Excel, if I wanted to add a new column to do something, that I would go through and I would put that column in, and maybe I would multiply by a value or subtract or do some kind of calculation. I do this all the time in Excel. You can do the same thing with pandas. Is you just create a new column, and then notice what I do is I say I want you to convert the existing date column, and I want to overwrite it, and I want to make it a date time type. So I'm telling it to have special characteristics. And this is similar again to Excel, where you could say I want this column to be numbers, or I want this column to be text, or I want this column to be financial data like currency. And then once I do that, I set this here. I say set index to date. So now I want, instead of the index to be numerical from 0 to 1, I want the index to be date related, right? So now I can sort by dates. And then what I do is I print this out. Notice now how it's different. Before the index, if we go back up here, all the way to this ingestion here, notice that the index is just 0, 0, 1, 2, 3, 4, 5, right? It's just a number. But now, because I went down to this, I can make the index the actual dates. So this gives us special abilities. And if we go to filter results by date range here, you can see I say from date time, import date, time delta, and now I can look at different time ranges. So I can say, I want to see what happened yesterday, or I want to look what happened 2 days ago. And then this is all you do is you say, here's today, and I want to look at the day before, which is today minus the time delta 2 days, right? So I want to look at 2 days earlier. And then if we go down and we put this into a query, if you use df.location, that gives us the ability to filter on some kind of a delta. So this says 2 days ago, right? I want to see what happened 2 days ago, and it will show us that particular time frame, which is in this example would be February 4th, 2021. And I can look at that exact interval. So there's some very powerful things that are much easier to do by using code than by necessarily using Excel. I like Excel, and that's also a great tool to use, but sometimes it's cleaner to use actually a programming language to do the same thing. So if you want to explore this, I think what you can do is you can make a copy of this notebook and play around with this and play with different deltas and explore it. I think that's one of the best ways to learn these kind of techniques. Now let's look now that we've got that, let's look at the distribution of the data by that particular date. So you can see here, right, I can put this into some form of kernel density plot, and it will show me that this is the number of deaths based on each state, right? So that the median is here, but we have some things going over here that are very high, right? So that would be, as a data scientist, I might want to look at that. That mostly things are fairly low in terms of states, but it looks like there's some regions that are hotspots, right? So we may want to look at those hotspots. Now, another thing you can do is you can also start to do advanced queries that do things like show the highest death and case counts. And in this particular example, what I can do is I can say, here's the current data frame. Again, look at the last 2 days ago, sort the values by death cases. So what's nice about the sorting is similar to Excel, is that I can sort by first the deaths and then by the cases, and then it lets me visually look at what's happening. And we can see here that, in fact, in the last 2 days, the leader in deaths was actually in New York. So they're actually leading the United States and on 205, and then in 204 they're also leading, and then California would be number 3, would be 43,000, and then 204 there would be 43,000. So you can see that, in fact, these are the hotspots in the United States, and these are the numerical counts, right? New York, California, Texas, Florida. Now, the advantage of looking at this kind of a format as well is if you read the news, you'll see the news, they're trying to sell newspapers, or you clicking on their website, and they say, like always something controversial, right? So that, but if this is the data, you can look at the data and you can just figure out yourself what's happening. And so I can just look at this data and I can see that the places where there's the biggest problem are New York, California, Texas, Florida, and Pennsylvania all have very high death rates in those states. And so those would be places that if I lived in those regions, I think you should be very cautious because there's a peak outbreak. Now, again, if I look at this, this gives us kind of the shape of the different states as well. So that's kind of a pulse check. And then if I want to look at, let's say, the top states, right, you can see that basically some states have they're double because they're able to be multiple days in a row. They're double, right? And so you can see that again. The New York, California, Texas, Florida, Pennsylvania are all the top locations. And if I want to remove some values, like that column FIPS doesn't really help us, I can just drop it by doing .drop right here. So I'll go ahead and drop this real quick. There we go. And now if I want to look at the unique values here, we can see again, I can drop the dupes and see California, Florida, New York, Pennsylvania, Texas. Those are the locations that are problematic in the United States. The set command is a nice command to know about. What it is in Python is it's a data type that allows you to deduplicate the values inside of a set. Now let's go ahead and do a little more sophisticated plot. This particular plot uses Seaborn again, which is a very common data science library. And what I first do is I set the figure size. So I say, I want to make the figure a little bit bigger so that I can plot a lot of states at the same time, because I want to visually look what's happening all in one chart. And so then what I do is I use this a separate command called ax, which creates a new axis, and I do sns.lmplot, and I put the cases and I put the deaths. I specifically put the height of each one of these states, right? So I set it to be 3.5, and then I say I want the column to be the state, and I want to wrap at about 5. So I'm basically just doing some manipulation of the size and what shows up here. I want the color, so I want each state to be its own color so it's easy to look at. And then I want to set the palette, and that's just the color types, like what are the colors I can choose from. And then the data will be the new data frame, remember that I picked before. And then I do subplots, right? So I do a subplot, and I even can adjust the space. So the idea here is that you can highly optimize the appearance of plots, which is more powerful than you could do in Excel. Excel is great. You can do all kinds of plotting, but the power with this is you can literally turn every knob. You can do anything you want because it's code, and so it's more configurable. Now, this is from a long time ago. I think this is maybe from March last year. So when I rerun this, the data will be very different. So let's rerun it again. That's the other thing that's great about this notebook that I gave you, is it dynamically updates, because I am pulling the data from New York Times, and they have a CSV file that updates every day. Every day it gets different. So if I click this here, it'll regenerate, look, very different charts here. And so we can see that we're just looking at the top 5 states, and notice that in terms of California, they could have a problem in California. Look, see this? You can see that this was initially they were able to flatten the curve, but it looks like right about here recently, maybe the last month or so, it's been trending up, and in fact the deaths are about to go into an exponential range. So I can see like there's a little curve here. Texas, if you look at the number of deaths, they seem to be actually linear, between a relationship between cases and deaths. Florida, maybe we can see a little bit of exponential growth. New York was exponential for sure. Remember at the very beginning of the pandemic, they had the biggest problem. And then they significantly flattened and went more linear, but we don't know. Is this going to peak back up again? And then we see there's a new one, Pennsylvania, which appears to be starting to be exponential. So again, as a data scientist, what's great about using these tools is I can really look at a lot of things on my own and make my own discoveries, without having to go to the news and who knows who these people are, what they're saying. I can make my own conclusions and look at the data myself, which again tells me I would not visit California if I don't live in California anymore. I used to, but I think this would be of all the states in the United States, I think this would be a very dangerous state to visit. Okay, interactive plot of the top states. I also can do other approaches as well. So What if I said from the beginning of the pandemic in the US, which was 2020, roughly like March 8th, that was really when things started to take off. Let's sort the values and then look at what happened. So you can see there's almost nothing in Pennsylvania, right? We see there was 0 deaths in March of 2020. But look, we see Pennsylvania now has got per day 30,000 something deaths. So very big difference in not even 1 year. Now let's do a different kind of plot. Now this is a library that's called Plotly, and what's useful about Plotly is that it allows you to do interactive plots and interactive data visualizations where you drag your cursor over it. So I use the importplotly.io as PIO, and then I pick a renderer called Colab, which makes it work well with this Google Colab Notebook. And then I say import Plotly Express, and I just do a scatter plot. So I put the top states here, and then I put the index for it so that it'll have the dates. And then my Y is a cases. The size will be the deaths. So the more deaths, the larger the bubble. And then the colors will be state. And then the facet color will be state as well. So if we look at this, this is from a long time ago. So let's watch, I'll rerun it again. And it will be very different visualization. There we go. So this was before it was New York was going, was really peaking, but now things have dramatically changed. In fact, and again, you can drag this over here, look, and it'll show you. You can look visually down here. So this to me looks like, at least looking at this visualization, I think Texas doesn't look good either. I think Texas, in terms of the cases, it looks like it's growing very, very sharply. California as well looks like the cases are exponentially growing up, and the bubble size obviously is the largest in California, Florida as well. So I think by visualizing the data and being able to explore it like this really adds a lot of power to doing your data visualization. So let's keep going down here and let's look at some other ideas that we can explore in this particular data set. So a lot of times when I'm doing some kind of a data visualization, when I'm just exploring the data, it's a little bit like playing music or playing basketball or, writing a book or something like this. I just try ideas out. So I think it's totally fine when you're doing exploratory data analysis to just have ideas. And the ideas could be bad ideas, that's fine. But this is where you could try those out. So here's one idea would be, maybe I want to look at, so in the United States, there's actually a large epidemic of diabetes, both pre-diabetes and also diabetes that's full-fledged diabetes. And part of this is because the population of the United States eats too much processed foods, and the processed foods contain a lot of sugar, and they also drink sodas which are contributing to diabetes. And so I wanted to see if typically there's a relationship. My intuition would tell me that people that consume large quantities of sugar oftentimes are not as educated, because I think many people know that sugar is essentially a toxin, that it has some of the same characteristics as a poison, right? The more you have sugar, the worse your health gets. And so you could use this as maybe an idea to look at what's happening with COVID and say, well, if someone would have a lot of sugar, again, this is an idea, it may not pan out, maybe they also wouldn't take precautions. Like maybe they wouldn't wear a mask because they just don't care about science, right? So I could look at this and pull in another data set here. So let's go ahead and look at this other data set. And this is a sugar data set from the year 2003 from the CDC of the United States. And so what I do is I put that sugar data set inside, and I clean it up a little bit so that I can pull out some values. And look what I have here. We have all of the states in the United States. We have the sugar intake by state. And so you can see here, like if I wanted to put all of them, let's put I don't know, like 30 or something like this, and let's look at a larger amount. You can see that there's some states that have very high sugar intake. Like this would be the state that has, for the population that did not graduate high school, right? So the lowest educated portion of the population, you can see that the sugar intake starts to get very high, right? So like you can see that college educated people in Louisiana, they limit their sugar intake. But even in California, the sugar intake grams per day is 11 for college educated. So it's directly correlated with education. The more education you have, the lower your sugar intake is. The least educated you are, the higher your sugar intake is. So again, in some of the southern states in the United States, Louisiana, Kentucky, and you look at the people that did not go to graduate from high school, they have very high sugar, like in some cases 5 times more sugar intake. So this, to me as a data scientist, this sees like maybe they're not very cautious people, right? It's possible that some of this population doesn't care about risk, right? They're not concerned about their health. So again, my assumption would be if they don't care about getting diabetes, maybe they don't care about getting COVID or passing COVID around. So that's a hypothesis. We would have to check it out. So if we scroll down here, what I would do is I would take that data and I would merge that data frame with this data frame. And so we can see here that the CDC employed, I can take the employed intake daily here and then take the state, and then I could run this analysis again. And so I just merged those all together, right? So I just merge the sugar intake with this data set. So what's great about this is now I have, this is called feature engineering, is I can start to see, can I create a prediction, because again, at least my intuition tells me that if you're uncautious with one thing, then probably there could be some problems happening in terms of education. So what else could we add? So again, this is I'm just trying ideas out. We don't know, but this is from 2016 election in the United States. Probably we could also add the 2020 as well. That would be a good one. When I first did this analysis, this was before the election in the United States, but there may be something happening as well, whether it's a Democratic state or if it's a Republican state. There may also be something. We don't know. We would just do a hypothesis. So how would I do this? I would grab another data frame here. In this case, this would have the electoral college votes from 2016. Again, we could grab the ones from 2020 as well. And I look at the state, and I look at the votes here, and then I look at the winning party, and I put those in. So now we have 2 new features to mix in with the COVID data. And if I scroll down here, I can do the same thing. I can just say merge, and notice how I merge here is that you need to have something that has the same column name, right? This says state, right? I had the state here, and I have the state here. Same as up here when I merged this data into the sugar data. Same thing. I said merge on state. So that's the only thing you really need to care about, is if you're merging data frames, make sure that you're merging on the same name. There we go. So let's go ahead and run this. Let's see what happens here. There we go. So now we've got all this data in one location. Now this is the next step that typically people do when you're doing machine learning. We're not there yet, but one of the things that is important to look at when you're doing data science, you're trying to create a predictive model, maybe predict the deaths in a state, is that you look at the correlations, and you can even put it into a heat map as well, which we'll show in a second. But in this case, the data frame in Pandas has something called .core, and this method will show what everything is correlated with everything else. So for example, visually now, let's see, my intuition would tell me that deaths would be positively associated with the sugar intake, but for some reason I'm wrong. So this is science, right? You figure this out, is that I don't know why you would think that more people would die that were cautious. We're not cautious, but it's the opposite. So somehow the sugar intake is not. It's negatively correlated with deaths. It's less correlated with cases. So it's still negatively correlated, but that's not what I expected. And then the same thing with is that depending on what political party you're with or whatever, that some people might think that Democrats are more cautious than Republicans potentially. At least politically, a lot of times that's what you hear. But then if I look at the data shows that the death rate is much higher. It's more positively correlated with Democratic populations and negatively correlated with Republican populations. So we don't know why this is happening. I mean, one thing that could be happening is that the Democratic regions are typically very dense, so there may be a higher population density in those areas. So I think, again, this is the point of science, is to look at things and try to figure it out. So now I can use this Plotly map here, and what I can do is I can plot the correlation as well inside of here. And so you can see that these Plotly plots here are pretty neat because they let you visually see what's happening, and you can change the color scheme or do whatever you want, and even share this out with other people. So not that this is necessarily the only thing that you can do is look at COVID data. Maybe many people don't want to look at COVID data, but the techniques, I think, are good techniques to look at. And then later, if you want to take all this data and you want to share it with someone else, another thing that you could do is you could always take the new data frame that you created. This is important to be aware of, and you can say .toCSV. And what this does is it allows you to write it out to a new CSV file. And in fact, we can go to this icon, to this directory here, files, and notice that this should populate inside of this file. So there we go, COVID EDA CSV. And if I click on it, I can now download it just like that. And then if I wanted to, I could actually pull this into a spreadsheet, and we could take a look at it. So let's see, like, I could go to maybe a Google Drive here, and I could make a new spreadsheet. Here we go. Here's a new Google Sheet. And then I could say File, Import, and then I could import that document that I just downloaded, which should be in my downloads directory. Here we go, COVID EDA. And I could also look at it like this. Sure, that looks good. Let me just say yes. Let's just make this a little bit smaller. Import the data. Perfect. There we go. Now we have the data in a spreadsheet. And then if I want to, I can also share this with other people. I could also do similar visualizations like I did, but with the Pandas environment. So a lot of times too, this is a good technique, is to go back and forth between spreadsheets and a notebook. Now, one of the things that I'll do as well is show that this is the more of a common data science approach, but there's more tools that you can use other than just a Pandas plus Jupyter Notebook or a spreadsheet. And in particular, there's an emerging category of tools that are codeless tools, or low code, no code tools. So let me just briefly cover this real quick, is that I'm going to go to the AWS platform, which you can create a free account very easily. And the AWS platform allows me to do lots of interesting techniques without writing any code. And so I'm going to log in here real quick. And in particular, what I can do is I can go to a service called Comprehend. And this service allows me to do sentiment analysis right inside of a chart here, and look at what's happening. Also look at key phrases, look at languages. So let's say I went to the New York Times. Now that I'm a data scientist and I'm like, okay, I want to find out more information. I have all this other research, but I want to add some text to it. So I just find something from New York Times. Here we go. What it's like to give COVID vaccine. Sure, let's take this. And I could just grab the text out of here. Although this is a bad one because there's no text. Let's go to this one. Here we go. We'll just grab all the text here. I'll just do a Control A, or just grab it like this. There you go. That looks good. Copy it, and I can just paste this in. So I don't even need to be a software engineer. I can just paste this in like that, and I'm going to analyze this article now. And notice that I just click this button, Analyze, and then what it does is it does a bunch of different techniques. One of the things that it does is that it finds all the entities inside of this article. So I almost can read the article without reading it, right? So this could maybe even allow me to read more articles than I possibly could have time for. I could put all of them inside of this. And look, I can pretty much see what this library is about, right? That it's in the Sunday magazine. There's some stories, and there's a woman called Laura Holson, and there's another one called Moises. And maybe I could just separately look them up. Maybe I don't want to read his opinion piece. I just know that there's two people. There's something going on with them. I'll go for a search. That's again just the entities that are extracted, but also I could find key phrases, right? So here's key phrases. We can see the article is about long haul COVID. It's shows legacy chronic illness. There's two stories. Again, I can pretty much figure out what's happening without having to read the person's article. And I also, if I want to, I could detect the language in English. I could also look at in this like personally PII, which is personally identifiable information. So let's say I was wanting to make sure that there was not medical records that are leaked out, and I was working at a hospital. This might be something I would look at as the PII, the personally identifiable information. We see like maybe those are things that we need to watch out for. Another one is sentiment. So we can see that this article is mostly neutral or positive. That's the combination of things. Really, much of it is not negative. And then also I can grab things like syntax, so I can even figure out parts of speech. So this would be a zero code. This would be a no code solution to help me create a story and visualize. Now, there's even more that I can do as well. And one of the things that I can do, I'll just grab the same text on this platform, is I can do transcribe, or actually translate. And let's say I was grabbing the data from another language, like maybe it was in Portuguese or Spanish or something like this. I also can automatically translate it. So I now have additional information. Let's translate this to maybe Portuguese here, right? On the fly, boom, it translates it. So I also could not just find articles from my region, but I could manually put them in and translate them, which adds a lot of additional insights that normally is not available to a data scientist. Like there could be something that's happening in a particular region where they have really good information about some problem, and the only way to get access to that information is to automatically transcribe. So I can paste it in, or there's an API as well. If you're a programmer, you can use the Python API to access this. So again, those are two kind of basic no code, low code techniques. Let me show another one that you can do as well called Rekognition. And so Rekognition is another good technique here. And let's try out this demo here. And if we go back to this article, remember that it had a picture here. So what I'm going to do is I'm going to take this picture, and I want to see what's happening in this picture like this. I'll just screenshot it like that. And then I will go back to this, upload it, and we'll go again to my desktop, and let's just throw this up here and see what we can find. Now, we can immediately find all the information out about what's happening in this picture, right? We see that there's a person, we're in a clinic, hospital, operating theater, shower, faucet. So there's a lot of value in these, again, no code, low code tools as a data scientist. And in fact, I mean, I could write no code and I could come up with a very interesting story. And maybe I would just take a bunch of top stories for a region, screenshot them, put them into a directory, and then just go through and find all the information out about them visually. Now, let me show you, though, a little bit more, since I've shown the natural language processing tools, I've shown the translation tools, and I've shown the visualization tools. Let me show how you could actually also programmatically do this. It's optional. You don't have to do this, but let me just show you how you could do this. The way I like to do this is I'm going to go to AWS here, and I'm going to go to something called Cloud9, which is a cloud-based development environment. And if I go to this cloud-based development environment, I can just create a new environment, just like this, and we'll call this, COVID exploration, like this, and I can say next step, and I would just leave everything default. All it says is you can use a free tier instance as a student. Go next here, and then we'll create this environment. And what this will do is it'll allow me to, almost like Google Colab, it allows me to have a cloud-based development environment to play around with some code, try some different ideas out here. And what's great about using the environment that's native to a cloud platform, either it's Azure has their own Cloud Shell, Google has their Cloud Shell, AWS has their Cloud Shell, is that it's much simpler to build solutions out for that particular cloud platform if you use their cloud-based tool versus doing it on your desktop. So that's what we'll do is really quickly, I'll show you a couple things that you can do by using a cloud-based development environment. So this will take just a second here. This only takes like maybe 10 seconds or so. Let's go here. Okay, there we go. So what I typically do when I first start building out a code solution is that I create a Python virtual environment so that I can import libraries. That's typically the approach. So I'll do this. I'll say Python 3-m venv, and I'll make a virtual environment. And all this does is make it so that the libraries that I install are in a certain directory, just like this. There we go. And then the next thing I'll do is I'll source that environment. So I'll do source tilde venv bin activate like that, right? So this will source the library. And then once I've got this running, I like to use a tool called IPython, which is like a terminal version of Colab or Jupyter Notebook. So I'll do this. I'll say pip install IPython like that. Once I do this, it'll install this library for me. And then I also will install the SDK to talk to AWS. So I'll say pip install Boto3. There we go. Now that I've got that, I can pretty much play around with different things and try new ideas out. So let's go ahead and do this. We'll type in IPython and notice that I can say, import Boto3, just like that. And Boto3 is the interface that can talk to any of those tools that we were just playing around with. So if I want to see comprehend, for example, I could say Boto3.client comprehend, at least I think this is. Yeah, and then I could say comprehend, and I could make some text, and we could say like, the sky is blue, and it makes me happy. Like something like this. I can say comprehend dot, and I can do a dot, and it should show me create, or there should be like a sentiment analysis endpoint. So I can look it up real quick what that exact method is. So we can say Boto3. You can go right to the documentation and notice that it's got every possible API on AWS. So I'm going to look for comprehend, which is the one I was using. Here we go, comprehend client. And let's figure out how we do sentiment analysis. So let's see here. Detect sentiment. There we go. So that's what I want to do. And it just takes a text string and language code, right? So I can just paste this in. So I can take a look, and maybe I'll even be lazy here, and I'll just go like this, and I'll just paste it in here so I don't have to look it up. There you go. And we know that it needs a text, and we're just going to need a language code. So we'll say comprehend, detect sentiment, and we'll say text is equal to the text string, and then the language code would be equal to English. And let's see what happens. There we go. We can see it's got that string is 99% positive sentiment analysis. So I also could programmatically do things like pull articles down, and I could even do this in a Jupyter Notebook or something like that. So in a nutshell, I think these ideas that we talked about here are important ideas, and I'll just recap them really quickly. As a data scientist, I think the Colab Notebook in particular is a great resource for you to play around with, and I would recommend using the approach of ingestion, exploratory data analysis, modeling, conclusion. If you have lower skill in programming, you can still use this approach and even use the off-the-shelf tools where you can just cut and paste things and even just put the screenshots inside of a notebook like this and share it. If you do have programming skills, you also can go and use things like Cloud9 and programmatically access resources, which is a great way to do data science. Congratulations, you finished the Python for Data Science in 1 hour. You're ready to build a portfolio. The next steps that I would recommend would be to create a Colab notebook with an ingestion phase, a EDA phase, a conclusion phase, a modeling phase, those 4 components. Put that into GitHub, build your data science portfolio, and you're off to the races.